Europe and Russia, Lesson 17, Russia's Varied Landscape, Physical Processes at Work. Introduction. In 1687, an English scientist named Isaac Newton proposed an amazing idea. He suggested that humans could launch a craft or artificial satellite into space that would orbit Earth just as the moon does. Almost 300 years later, Newton's idea finally came to pass when in 1957, Russian scientists launched a satellite called Sputnik. Since then, a number of countries have collectively launched more than 5,000 satellites into space. Cameras and other instruments carried by satellites have given humans a new view of Earth from space. Geographers use these satellite images to study Earth. Among other things, these views of Earth from space show how landscapes develop and change over time. It may seem like mountains and valleys have always been and will always be where they are today, but the reality is that Earth's surface is forever changing. Physical processes, or natural forces, are always at work on the landscape. For example, some physical processes build up land into mountains, whereas others wear down land into valleys and plains. Satellite images help scientists study the forces of change that shape these physical features. In this lesson, you'll learn about 4 physical processes that shape our Earth. You will also learn how these processes have changed Russia's landscape. Russia is the largest country in the world, covering almost 1/8 of the world's land surface. Because of its great size, Russia has a large variety of landscapes to explore, and scientists are able to see how many physical forces are at work. The essential question for this chapter is, how do physical processes shape Earth's landscape? The map at the center shows the physical landscape of Russia. The 4 drawings around the map represent physical processes that have shaped the Russian landscape. 2 have built up the landscape and 2 have worn it down. Keep this illustration in mind as we try to answer the essential question, how do physical processes shape Earth's landscape? The geoterms for this lesson are erosion, the gradual wearing away of Earth's surface by the action of wind, water, ice, and gravity. Glaciation, the creation and movement of glaciers. Physical processes, natural forces that change Earth's physical features, including forces that build up and wear down Earth's surface. Tectonic movement, the movement of plates below Earth's surface. And volcanic activity, the formation and eruption of volcanoes. The geographic setting. Covering almost 7 million square miles, including large parts of Europe and Asia, Russia is the largest country by landmass on Earth. It's so big that it includes 11 of Earth's 24 time zones. By contrast, the continental United States has 4 time zones. The western part of Russia is one large plain that extends eastward to the Ural Mountains, which separate Europe from Asia. East of the Urals lies Siberia, another vast plain that is part of Russia. High plateaus, icy mountains, and deep valleys surround Siberia. Physical processes that begin deep inside our planet have shaped this varied landscape. The planet Earth was once a liquid fireball. Even though Earth has been cooling for more than 4 billion years, temperatures remain so high deep inside the planet that in some places, rock and metals are a fiery liquid. At the center of the Earth lies its core, which consists of 2 parts, the inner core made of solid iron and the outer core made of liquid iron. Earth's core is the hottest part on the planet, with temperatures that may reach over 10,000 degrees Fahrenheit. The next layer out from the core is called the mantle. The mantle is made of molten or liquid rock called magma and accounts for about 2/3 of Earth's mass. The outermost parts of Earth is called the lithosphere. The lithosphere includes a layer of solid rock and above that, the crust, the only cool layer of Earth. The crust is where we live. 2 physical processes build and shape land from below the crust: tectonic movement and volcanic activity. Tectonic is a Greek word that means builder. Tectonic movement occurs inside Earth and results in changes on the planet's surface. Over millions of years, tectonic movement builds up mountains. Additionally, it triggers earthquakes. Volcanic activity includes the formation and eruption of volcanoes. Like tectonic movement, volcanic activity also begins below Earth's crust. When volcanoes erupt, they can change the landscape suddenly and dramatically. Two physical processes work above Earth's crust to reshape landscapes: erosion and glaciation. Erosion is the wearing away of Earth's surface, most commonly by the forces of wind or moving water, but also by the force of ice or gravity. Glaciation is the formation of large, thick masses of ice called glaciers. The weight of the ice exerts pressure that causes the glaciers to move very slowly across the land. This movement can gouge out deep valleys, carve and polish mountains, and push piles of rock and soil ahead of them. Erosion and glaciation create change very slowly. These four physical processes have been changing Russia's landscape for millions of years. These processes have worn down plains and mountains and have carved out canyons and valleys. In this lesson, you'll learn more about how these four physical processes have shaped not only Russia, but also the rest of our planet. How tectonic movement shapes Earth. Early in the morning of April 18, 1906, a terrifying earthquake shook the city of San Francisco, California, causing massive devastation. Trolley lines snapped like threads, and buildings crumbled like card houses, wrote one eyewitness. The cobblestones danced like corn in a popper. Hundreds and perhaps thousands of people lost their lives. Hundreds of thousands more were left homeless. No one at that time understood how or why earthquakes happen, but today we know that they are caused by tectonic movement. Scientists solved the mystery of earthquakes in the 1960s when they discovered that the lithosphere is broken into huge pieces called tectonic plates. Earth's land and seas rest on this plates, which lie below the surface of the planet. The plates float like rafts on Earth's liquid mantle. Tectonic plates move in three ways. They can move away from each other, they can move toward each other, or they can scrape sideways past each other. When two tectonic plates collide, one plate usually slides under the other. Tectonic plates are incredibly heavy. When they meet, friction can lock them into place for long periods, allowing enormous pressure to build below Earth's crust. When the pressure gets too great, the plates come unstuck and move with tremendous energy. We feel this sudden movement as an earthquake. When tectonic plates collide head-on, mountains can develop in two different ways. The first way occurs when the pressure of colliding plates forces Earth's crust to fold or wrinkle without breaking. The resulting folds form mountains. Examples of fold mountains include Appalachian Mountains in the United States and the Ural Mountains in Russia. The second way in which colliding plates create mountains is when their collision causes the crust to crack into giant blocks. The cracks between these blocks are called faults. As the pressure builds, the blocks of crust tilt and tip, and some tilted blocks then slide upward along fault lines to form mountains. The Sierra Nevada mountain range in California is made of fault block mountains, as is the West Sayan Range in Russia. Over millions of years, the slow movement of tectonic plates creates mountains. When plates collide, they push rock upward to form mountains. Obviously, this takes a very long time. You don't just get a mountain in a day. But we can see the tectonic plates below. They are a large piece of Earth's lithosphere that can move to create mountains, volcanoes, and earthquakes. They do all of the above. We also see a fault, which is a crack in the Earth's surface, so we can see that the plates are kind of smushing to each other and forming cracks. We know a fault mountain is a mountain formed when a block of Earth's crust slides upwards along the fault line. So we have our fault, and then it's coming up, and that creates a fault block mountain. A fold mountain is when the mountain forms when colliding tectonic plates force Earth's crust to wrinkle or fold. So like when we did before, and you take your hands facing each other and you smush them together, and one kind of goes up, that was the fold mountain. That's what's doing. Signs of tectonic movement in Russia. Russia covers a large part of both Europe and Asia and includes several mountain ranges. These mountain ranges tell the story of how tectonic movement can shape a landscape. The Ural Mountains and Western Russia are considered the dividing line between Europe and Asia. Although Europe and Asia form one huge landmass, sometimes we call it as Eurasia, this division in two continents makes good geographic sense. The Urals mark the place where two tectonic plates meet beneath Earth's crust. Over millions of years, pressure from these two colliding plates has pushed the crust upward to create the Urals. The Urals slice through Russia from north to south and separate the northern European plain to the west from the West Siberian plain to the east. Weird. The Urals are fold mountains, formed as the two underlying plates cause Earth's crust to wrinkle. When erosion has worn these mountains down into rolling hills, other parts of these mountains retain their rugged peaks. Mount Madaraga in the northern Ural Mountains is sometimes called Bear's Paw because of its jagged ridge. You can see in the picture to the side, there's Bear's Paw. The Caucasus Mountains are in southwestern Russia. They run west to east on a narrow strip of land between the Black Sea and the Caspian Sea, marking a southern dividing line between Europe and Asia. Like the Urals, the Caucasus Mountains are fold mountains. They also include volcanic formations and glaciers, which carve the jagged landscape. Mount Elbrus, the highest peak in the Caucasus Range, stands at 18,510 feet and is an extinct volcano. The West Sayan Mountains are in southern Siberia, just west of Lake Baikal. Around Lake Baikal, major faults separate high mountains and plateaus from deep valleys and basins. The West Sayan Mountains are fault block mountains in which erosion has worn away loose soil and rocks from the peaks. This process has left behind steep ridges and exposed layers of rock on the upper slopes of the mountains. How volcanic activity shapes Earth. Like earthquakes, volcanoes can reshape the landscape with awesome force. In 1883, an erupting volcano destroyed most of Krakatau, an island in Indonesia. People heard the explosion more than 2,000 miles away in Australia. Clouds of ash flew 20 miles or more into the air, and dust from the eruption created colorful sunsets around the world. In the end, 2/3 of Krakatau disappeared into a hole under the sea. As you read earlier, hot liquid rock called magma is located beneath Earth's crust. This molten rock is always moving and sometimes pushes its way to the surface through cracks in the crust. Scientists call this place where magma reaches Earth's surface a volcano. When magma erupts from a volcano, scientists call the liquid rock lava. So it starts off as magma, and as soon as it comes out of the volcano, it is now called lava, just to differentiate where they found the liquid rock. Volcanoes often emerge along the edges of tectonic plates. The hot magma rises through the cracks between two plates or at weak points in Earth's crust called hotspots. Regardless of the process, the result might be a single volcano or an entire chain of volcanoes. The Hawaiian Islands are an example of a chain of volcanoes. Some volcanic eruptions are relatively quiet, with lava oozing out or spraying like a fountain. At other times, volcanoes can explode with enormous force, literally blowing their tops off. In 1980, a huge volcanic eruption shook Mount St. Helens in the state of Washington. Afterwards, Mount St. Helens was at least 1,300 feet shorter than it had been before the eruption. Volcanic eruptions hurl tiny... Volcanoes also alter the landscape in another way. Violent eruptions hurl tiny bits of rock and volcanic ash into the air in an enormous cloud. Eventually, that hot ash falls to Earth, where it can dramatically change the surrounding region. If thick enough, the ash can bury vegetation and even people and buildings. Sometimes, ash mixes with steam to create a fast-moving mudslide capable of burying everything in its path. After a violent eruption, the land around a volcano may collapse, creating a large crater or hole. So we see, we're going to start from the very bottom. We have our magma chamber, which is the place way deep underground where all the magma collects. Then the magma will go up through the main vent, where the magma can burst through Earth's crust. Pop off the crater, the hole at the top of the volcano where the land around the opening has collapsed. So that's how the smoke and the steam and the magma can start coming out. And then, poof, magma erupts out of the volcano, and we now call it lava, which is the same liquid rock. Nothing has changed, except that now lava is on the outside of the volcano instead of inside. Signs of volcanic activity in Russia. Two immense tectonic plates meet under the easternmost edge of Russia. As a result, this area is one of the world's most active earthquake zones. It's also the location of several volcanoes, most of which are on the Kamchatka Peninsula. Some volcanoes in this region are dormant or inactive, meaning that they have not erupted for a very long time, but others continue to be active. When these volcanoes do erupt, they can change the landscape for miles around through lava flows, mudslides, and deposits of ash. They can cause numerous deaths and destroy entire cities. Some eruptions also change the shape of the volcanoes themselves. Oh boy. The Klyuchevskoye volcano rises to a height of 15,584 feet outside of the northern part of the Kamchatka Peninsula. It is the highest volcano in Russia and also the most active, with smoke continuously billowing from its crater. In 1994, Klyuchevskoye erupted with tremendous force. Rivers of lava flowed down the sides of the volcano, and a cloud of gray ash rose almost 12 miles into the air. Still more ash combined with melting snow to trigger major mud flows. Other eruptions have occurred since 1994, but they have not been as severe. The Malý Semeníček volcano rises out of the center of the Kamchatka Peninsula. It is characterized by a Troitsky crater, a large crater at the top that is filled with hot, blue, acidic water. The crater formed during an eruption 400 years ago. And the Krenitsyn volcano is on Onikoden Island, which is part of the Kuril Island chain in the northern Pacific Ocean. During one of its eruptions, part of the volcano collapsed, leaving a large hole at the base of the volcano. Once the mountain cooled, the hole filled with water, creating a lake known today as Ring Lake. Here we have the Khmelnytskyi volcano. It's one of the 160 volcanoes located on Russia's Kamchatka Peninsula. Of these, 29 are still active. Khmelnytskyi has erupted 29 times since 1771. 29 times since right before the Revolutionary War. Crazy! Alright, that is all that we have for today. We talked about two different ways that, physical processes that change the Earth's physical features by building them up. We talked about making mountains by tectonic plate movement, and we talked about volcanic activity. Next time we meet talking about social studies, we're going to be talking about erosion and glaciation. find out how we can tear down and break apart some of the physical features of Earth. That's all I've got for you today. Have an amazing weekend, and I will see you again on Monday.